Hi, welcome to my video on the derivative of quotient rule number 2. Just more examples of the derivative using quotient rule. Find the derivative of each. Again, notice you have the cube root of x squared, which is one function, and you have x cubed subtract 4x squared, which is another function. This is a root, and this is a polynomial. So we want to find the derivative, so that's the prime. Again, that's f and g. The derivative is f prime g, f g prime with a minus sign over g squared. So here we go. And before we start though, we should recopy this root here, cube root. So this is x to the 2/3 divided by x cubed minus 4x squared. So we change the cube root to a fraction. So it's 3 is the denominator, so it's x to the 2/3. Now, let's do, this is f and this is g. So we got x to the 2/3 derivative times the g, which is x cubed minus 4x squared. Subtract, we have x to the 2/3, and we have x cubed minus 4x squared derivative all over x cubed minus 4x squared. And we do the derivative of x to the 2/3, so x to the 2/3 becomes 2/3 times 1 is 2/3, and we decrease the exponent by 1, so 2/3 minus 1 is, that's 1 is 3 over 3, so that's negative 1/3. So we have, that's 2/3, so we could have 2/3 x to the negative 1/3 times x cubed minus 4x squared, and we have x to the 2/3, and the derivative of this binomial x cubed is 3x squared, and negative 4 times 2 is negative 8x all over x cubed minus 4x squared, all squared. Now we have to multiply this out. So we got 2/3 times 1 is 2/3, and this is a 3, so negative 1/3, and when you multiply you add, so you're going to add on 3, and 3 is 9 over 3, so that makes it x to the 8 over 3. And 2/3 times 4 is negative 8 over 3, and we got negative 1/3 and 2, so negative 1/3 plus 2, 2 is 6 over 3, so that gives us x to the 5 over 3. And we multiply here, and we get a negative 3, and we got 2/3 add on 2, so 2/3 add on 2, 2 is 6 over 3, so that's x to the 8 over 3. Negative times negative is a positive 8, and we got 2/3 plus 1, and 1 is 3 over 3, so that's x to the 5 over 3 divided by, so just wanted to do one with some roots just to show you how it's working. And this becomes, now do we have any, we got to add these together, so this is x to the 8 over 3, this is x to the 8 over 3, so these two here are the same, so 2/3 subtract 3, so 2/3 subtract 3, so 3 is 9 over 3, so that's negative 7 over 3, so that becomes negative 7 over 3x to the 8 over 3, and these two are like terms, so it's negative 8 over 3 add on 8, negative 8 over 3 add on 8, 8 is 24 over 3, so that gives us 24, subtract 8 is 16, So that's positive 16 over 3 x to the 5 over 3. Notice that these two terms are the same, so I'm taking 2/3, subtracting 3, and I get a negative 7 over 3. These two terms are the same. Negative 8 over 3 add on 8, which is 24 over 3, gives me 16 over 3. And that's x cubed minus 4x squared all squared. So again, this is different with the roots, so I wanted to do one of those. And now we have another one, do the derivative of, so that's the prime, that's the f, and that's the g. And again, I write it out all the time. So it's, the derivative is f prime g, f g prime with a negative, and it's g squared. So here we go. I got a 3 cos x derivative times 2 to the x, subtract 3 cos x and 2 to the x derivative. Now I could have done the derivative of these right away, but I just wanted to write it down. This is the derivative of f times g, subtract f times the derivative of g. I'm just showing it to you, but I could have done this right away without writing this down. So 3 cos x, so the 3 is constant, so it's the 3. Derivative of cos is negative sine x times 2 to the x minus 3 cos x, and the derivative of 2 to the x is 2 to the x ln 2 all over, and if you go 2 to the x squared is 2 to the x times 2 to the x, which is 2, and when you multiply like bases, you add the exponents, so you get 2x, so it's 2 to the 2x. Or another way is 2 to the x squared. This is a power of a power, so that's 2 to the x times 2, which is 2 to the 2x. You can either do it this way or this way. Anyway, we have to simplify this now to put it in. Everything looks okay. But if you want, we have, let's see, we can simplify this. We got 2 to the 2x here, and there's 2 to the x here, and 2 to the x. So let's take out the negative 3 times 2 to the x. So negative 3, 2 to the x is here. Divide that into here, and you get sine x. Negative 3 divided by negative 1, 2 to the x, so that's negative, positive. Negative divided by negative, negative divided by positive. So we get 3 gone, so that's cos x ln 2 all over 2 to the 2x. And we simplify that, we get a negative 3. Notice 2, so 2 to the x divided by 2 to the 2x is, you can, because they're like bases, then this is 1 over 2 to the 2x minus x. Because when you divide with like bases, you subtract the exponents. Now I could have done x subtract 2x and had 2 to the negative x, but that would have come out to be 1 over 2 to the x the same. So 2 to the negative x is the same as 1 over 2 to the x. So when you cancel here, like that, this becomes 2 to the x. So there it is. And sine x is left, plus cos x ln 2. So I just wanted to simplify that, because you always have, by simplifying, you always make the math easier when you move further in the problem. And again, I wanted to do an exponential there on the derivative. So the quotient rule is explained again with some more examples. And this brings us to the end of the video. Again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.